Okay, so this is 3.6. We'll call it A. I don't know if we'll need more than one video or not, but let's assume that we will. The name of the section is Function Notation, and it's really not too difficult. I'm going to simplify it by doing something that maybe I shouldn't do, but I'm going to do it now just because it's going to make life easier on you. Instead of using y when we're dealing with functions, we're going to use f of x. So what that means is the function of x. So let's say that I have an equation that says f of x equals 10x. That equation means whatever number I put in for x, I'm going to multiply it by 10 and get an answer. So for instance, if I was interested in putting 2 in for x, I would write this as f of 2 equals, and I automatically put a 2 in here, equals 20. So what we've got here is basically what value do I get when I put this number in this equation. So I could have that, I could have f of 4, and that would equal 40. So what I'm doing is I'm putting 4 in the function machine, and this is what it does in the function machine, multiplies it by 10, and it spits out an output. It spits out a 40. So this is just another way of writing y, but telling you what number is going to be put in for x to give you that y value. So if we were to look at any type of notation, it doesn't even have to be an f. It could be s of t equals 60 over t. That is a function. So if t is 1, I could write this as s of 1 equals 60 over 1 equals 60. So s of 1 equals 60. S of 2 equals 60 over whatever value we have here, because see, it's a t here. I'm going to put it over 2, equals 30. So therefore, s of 2 equals 30. So the function of 2, when I put it in this equation, I'm going to get 30. So basically, we put something in. We're going to call it an input. We have a rule to follow. If I can write rule. And it spits something out, gives us an output. So we have an f, the domain of f, our x value. We have a rule. And then we get an output based on that rule. So if our input was a 2, we'd have f of 2 equals 2 times 2 plus 3. And our output would be 4 plus 3 is 7. So our input is 2, our output is 7. We would write it as f of 2. So that's just telling us what number we put in for our variable equals 7. And that's pretty much what that amounts to as far as understanding that whole scenario. So let's look at a story problem here. Example 3. We've got a painting purchased as an investment, and it costs us, or cost you, $125. Not much of a painting. If its value increases continuously so that it doubles every 5 years, then its value is given by value is dependent on how much time goes by, v of t, so we know it's a function, equals 125 times 2 to the t over 5. Doesn't matter if you understand where this equation came from, if you understand what this is just the formula, and t is greater than or equal to 0. Because it's time, it has to be a number. Either no time has passed or years and years has passed. But it can't be a negative, so that's why they put that there. So we're talking about 5 years. If we're interested in finding out what this is worth in 5 years, what we would do is we would do v, and the time is 5 years. We're going to put a 5 there. And whenever we see a t, we'll put 5 years in. So whatever letter this is, when you get to the equation, you're going to put a number in for whatever letter you're looking for, it gives you. So there's a t here, so I'm going to put a 5 here over 5. 5 over 5 is 1. So v of 5 is going to be 125 times 2, which is $250 at the end of 5 years. So v of 5 equals $250. And we can make that time anything we want. Let's say we make it 10. Go up to our original equation, 125 times 2 to the 10 over 5. So v of 10 equals 125 times 2 squared. So 125 times 2 squared is 4 equals 500. So therefore, v of 10 equals $500. And that's what your answer would look like. Okay, let's look at example 4. We've got a balloon, shape of a sphere, bad sphere, with a radius of 3 inches. Use the following formula to find the volume and surface area of the balloon. Let's just find the volume. Here is the formula. That's an R. Okay, let's look at this. This is saying that the volume is dependent on whatever the radius is. So the radius of this balloon, if it changed, that would change the volume. So the volume is dependent on the radius. You can also look at functions that way. This is always dependent on whatever is in the parenthesis. So this one says the volume is 3. So if the volume is 3, then we just replace the R with a 3. So 4/3 pi times 27. And keep that there. And v of 3 equals, we can cancel that and make that a 9. So we have 36 pi. 4 times 9 is 36. So that gives us pi. So the volume of this balloon is 36 pi, or 36 times 3.1415, So we just multiply 36 times pi, we'll get the volume of the balloon. So that's what that means. Okay, let's look at example number 5. Example number 5 gives us something kind of goofy. F of x, so the function of x equals 3x squared plus 2x minus 1. So this is whatever number we decide we're going to put in for x. This is the equation we're going to put in, and then we're going to get an answer. So if it says, find f of o, well, that means that we are going to, wherever we see an x, put a 0 in there. Those go away, those go away. So f of o, or 0, sorry, why do I call it o, equals -1. What if I have f of 3? That is 3. So this is 927 plus 6 minus 1 should be f of 3 equals 32. So see what we're doing? We give you the equation, and then whatever number they give you, that is saying f of what number, or the answer to the equation given this number in there is going to be what? So when we put 3 in for x, we're going to get 32 out for y. Okay? So basically, when I say f of negative 2 equals 7, I'm saying that y is 7 when x is negative 2, and I put it in the equation right here. Okay? So when I put negative 2 in for x, I get a y value then of 7. So just to reinforce that a bit. Sometimes we're given two different functions, and we're supposed to be looking at both of those functions. So sometimes we'll say, okay, what is g of 2? Well, up here, we have an f. We don't have a g. So we ignore this one, and we go to this one, because g of 2 is equal to 2 squared plus 2, which is going to be 6. If I say f of 3, you are going to ignore this one because this doesn't have an f of 3. So what this does is it tells you which equation you're going to be looking at. And sometimes it just depends on several different things. But when they give you an f of 3 and several equations, you're only going to do the one that has the f there. And the same with the g. So as you're doing this, just something to keep in mind. I will let you look at example 7 and get what they're doing there, but I want to do example 8 real quick. So they give me a function f of x, and that is 2x squared. They also give me a g of x, and that is 3x minus 1. If they were to give me f of g of 2, and it looks like that, what they're asking you to do, and this is the part that as we get more and more into functions, I'll reiterate this. You always start in the innermost. So what this is saying is we are going to start with the g2. So we're going to start over here, put 2 in for g, and that gives me 5. So g of 2 equals 5. So 5 now goes in here in place of the g2. So this is going to be 5. So if g2 is equal to 5 when we put it in here, then we can put 5 there. So now what we've got is f of 5 equals 2, because we're going to bring this down, times 5 squared equals 25 times 2 is 50. So f of g of 2 equals 50. Okay, so we do this first, find out the answer, and then we take that answer and plug it into our f. Same thing if we go the other way. So see if I can get rid of all of this. And we have, again, f of x equals 2x squared. G of x equals 3x minus 1. Okay, B part of this is g of f of 2. And we'll get something different when we do this. So we're going to do the f of 2. So we're going to plug in 2 there. So f of 2 equals 2 times 2 squared equals 10. I'm sorry, 8. Where in the world I got 10? So f of 2 equals 8. So now whenever I see an f of 2, I'm going to put 8 in its place. So g of 8 equals, now I'm going to look up here. So G f of 2 equals 23. Okay? So that is it for 3.6.